Welcome to Omni Eyes. Tonight, we explore the shadows to uncover the incredible night vision secrets of the stealthy green lacewing insect. The darkness of the night hides many mysteries, but for some creatures, the absence of sunlight is merely an invitation to hunt. Episode 48 dives deep into the microscopic realm. We will discover how lacewings gather faint ambient light better than diurnal insects. Most daytime insects become completely blind when the sun goes down. However, the lacewing thrives perfectly in this pitch-black nocturnal environment. These delicate green predators are true masters of the dark. They rely on incredibly specialized eyes to navigate through the dense foliage. Their visual system is a marvel of biological engineering. It represents a highly advanced form of natural low-light enhancement technology today. Unlike snakes or certain technological devices, they do not use thermal imaging. They do not rely on infrared radiation to see warmth. Instead, they optimize their complex eye surface structure. This allows them to capture every single faint photon of light available around them. Imagine walking through a dense forest at midnight. To human eyes, the environment appears completely dark and devoid of any visual details. But for the lacewing, the forest is illuminated by the gentle glow of starlight and the pale reflection of the distant moon. Every tiny fraction of ambient light is carefully harvested. Their eyes act like extremely powerful microscopic light buckets, gathering the scattered photons. Let us take a closer look at the anatomical structure of the lacewing. Notice the large, prominent compound eyes on its head. These eyes are composed of thousands of tiny hexagonal units called almatidia. Each one functions as an independent, highly sensitive optical receptor. In daytime insects, these almatidia are isolated from each other by dark pigments. This prevents light from scattering and ensures sharp vision. However, this isolation also means that a large amount of incoming light is lost. That is a luxury night hunters cannot afford. Lacewings possess a different type of eye architecture, known as the superposition eye. This design is specifically tailored for extreme low light. In a superposition eye, the isolating pigments can retract during the night. This opens up the internal structure to maximize light absorption. Light entering through multiple lenses is expertly bent and directed towards a single central photoreceptor. This effectively multiplies the total gathered light. This incredible biological mechanism acts exactly like a massive telescope mirror. It collects scattered photons and focuses them into a brilliant image. As a result, the lacewing's visual sensitivity is increased by hundreds of times. They can easily spot their prey in total darkness. Watch as this silent hunter approaches an unsuspecting aphid on a leaf. The prey has absolutely no idea that danger is near. The aphid remains perfectly still, assuming the darkness will provide adequate camouflage. But the lacewing sees the aphid clearly in the moonlight. With swift and precise movements, the predator strikes. The enhanced vision guarantees a successful hunt, proving the immense power of this adaptation. This remarkable ability is not just fascinating for biologists. It holds incredible potential for advancing modern optical technology and human camera engineering. If you want to film in the dark without using artificial lights, you must study the lacewing. They are the ultimate masters. Traditional night vision goggles often rely on emitting an infrared beam. This beam illuminates the area but can reveal the user's position. For wildlife documentary filmmakers, shining an infrared light might startle sensitive nocturnal animals. It completely disrupts their natural behaviors and ruins footage. Military operatives face a similar problem. Using active infrared illumination is like holding a bright flashlight visible to anyone with similar gear. The lacewing's approach is entirely passive. It does not emit any energy. It only absorbs what is naturally present in the environment. True stealth requires invisibility. By mastering the art of low-light enhancement, these insects move through the shadows completely undetected by enemies. Engineers are now studying the exact microscopic geometry of the lacewing's eye surface. They hope to replicate this structure using synthetic materials. The surface of their eyes features anti-reflective nanostructures. These tiny bumps prevent light from bouncing off, ensuring maximum absorption into the lens. If we can apply these nanostructures to camera lenses, we could drastically improve the performance of sensors in extremely low light conditions. Imagine a smartphone camera capable of taking perfect, noise-free pictures in the dead of night without ever needing a bright LED flash. This biomimicry could revolutionize photography, surveillance, and space exploration. Nature has already solved the complex optical problems we are currently struggling with. The lacewing's delicate wings flutter silently as it moves to another branch. Its enormous eyes constantly scan the dark environment for movement. Even the faintest glimmer of light reflecting off a dewdrop is captured and processed by its incredibly efficient and complex visual cortex. Let us delve deeper into the physics of ambient light. Ambient light consists of photons originating from the moon, stars, and atmosphere. These photons scatter across the landscape, bouncing off leaves, rocks, and water. Most creatures cannot detect such low levels of scattered energy. However, the lacewing superposition eye acts as a photon magnet. It pulls these scattered particles together to construct a clear, bright picture. The biological lenses inside the eye are perfectly shaped to refract light inward. This refraction process is mathematically precise and highly efficient. Think of it as a funnel for light. The wide top collects the faint rays, concentrating them down to a single point. At this focal point, sensitive photoreceptor cells trigger electrical impulses. These impulses travel directly to the insect's brain for rapid visual processing. The speed of this processing is crucial. A predator must react instantly to the movements of its prey, even in complete darkness. This incredible neural pathway is highly optimized. It completely eliminates any visual lag, ensuring the lacewing strikes with deadly accuracy every time. Let us compare this to human vision. When we enter a dark room, our eyes take several minutes to adjust and dilate. Even after adjusting, we can only see vague shapes and shadows. We lack the specialized superposition structure necessary for true night vision. We are inherently diurnal creatures, designed for the bright sun. The lacewing, however, is a specialized nocturnal entity, born for the shadows. The evolutionary journey of the lacewing is a testament to nature's ingenuity. Millions of years of adaptation have perfected this optical masterpiece. Every generation of lacewings inherited slightly better night vision. Only the most successful nocturnal hunters survive to pass on their incredible genes. Today, they stand as the pinnacle of low-light biological engineering. Their eyes are far superior to most man-made night vision systems. Look closely at the shimmering surface of the lacewing's eye. The iridescent colors are a direct result of those microscopic, anti-reflective nanostructures. These structures trap the light, preventing it from escaping. It is a beautiful and highly functional feature that defines their nocturnal dominance. The night sky is never truly pitch black. There is always a faint, residual glow from the atmosphere, known as airglow illumination. The lacewing utilizes this subtle airglow to illuminate its surroundings. It transforms the dark, mysterious forest into a bright, easily navigable landscape. Observe the lacewing in flight. It maneuvers flawlessly through the tangled branches, avoiding obstacles with the agility of a daytime flying insect. This level of spatial awareness in the dark is astonishing. It proves that their visual processing is exceptionally fast and incredibly accurate. Researchers have placed lacewings in controlled laboratory environments. They gradually reduced the lighting to test the absolute limits of their visual capabilities. The results were absolutely staggering. The insects continued to navigate and hunt efficiently, even when the light levels were almost entirely zero. They can see in conditions that are 1,000,000 times dimmer than broad daylight. This is an unimaginable feat for human beings. To achieve this, the lacewing sacrifices some visual resolution. The image they see might be slightly blurry, but it is incredibly bright. In the dark, brightness is far more important than sharpness. Detecting the movement of a predator or prey is the ultimate priority. The lacewing does not need to read text in the dark. It only needs to see the silhouette of a delicious aphid. This brilliant trade-off is a perfect example of evolutionary optimization. Nature always finds the most efficient and practical solution to a problem. Let us return to the technological applications. Imagine integrating this biological concept into the next generation of autonomous night-flying delivery drones. Drones equipped with lacewing-inspired optical sensors could navigate safely at night without relying on heavy batteries for powerful external lighting systems. This would vastly increase their operational range and efficiency. The potential benefits for modern industries and search operations are truly quite staggering. Furthermore, search and rescue teams could locate lost individuals in dense forests at night without sweeping the area with highly disruptive spotlights. The applications extend to deep-sea exploration as well. The dark depths of the ocean share many similarities with the nocturnal forest. Submersibles equipped with these advanced sensors could observe shy marine creatures in their natural habitat without blinding them with harsh artificial lights. The lacewing teaches us that we do not always need to overpower the darkness. Sometimes we just need to learn to listen. By listening to the faint whispers of ambient light, we can uncover a hidden world teeming with invisible life and nocturnal activity. As the night progresses, the lacewing continues its relentless hunt. Its appetite for aphids makes it a highly valuable biological pest controller. Farmers and gardeners deeply appreciate the presence of lacewings. These silent guardians protect crops from destructive pests under the cover of darkness. Their extraordinary vision allows them to hunt effectively when other predators are asleep. They dominate the nocturnal ecosystem with unmatched visual precision. A single lacewing can consume hundreds of aphids in one night. This incredible efficiency is entirely dependent on their specialized superposition eyes. Let us visually reconstruct exactly what the lacewing sees right now. The dark forest background fades away, revealing a bright, glowing landscape. The edges of the leaves appear highly defined. The tiny aphid stands out clearly against the brightly illuminated texture of the plant. It is a completely different reality from our experience. To them, the night is merely an alternative version of the vibrant day. This specialized vision also helps them avoid predators. Bats and nocturnal birds constantly patrol the night skies, searching for delicious flying insects. The lacewing can spot the approaching silhouette of a bat against the starlit sky, allowing it to take immediate evasive action safely. Survival in the dark is a constant dangerous game. The creature with the best sensory equipment usually wins the nightly battle easily. Thanks to its superposition eyes, the lacewing is a reigning champion of this nocturnal arena. It perfectly balances hunting and defensive skills. Let us zoom out and appreciate the broader implications of this discovery. Nature serves as our ultimate research and development laboratory today. Every organism is a highly refined machine. They are optimized through millions of years of rigorous testing in the harsh, wild environment. By studying the lacewing, we unlock profound secrets. These discoveries can drastically improve our technology and enhance our understanding of optical physics. The field of biomimicry is rapidly expanding. Scientists constantly look towards the natural world for innovative solutions to complex modern engineering challenges. Next time you walk outside on a dark night, take a moment to look closely at the shadows surrounding the forest trees. Remember that while you are virtually blind, an entire ecosystem of specialized creatures is operating flawlessly within the pitch-black nocturnal environment. The green lacewing is an unsung hero of the night. It silently demonstrates the breathtaking power of natural, low-light enhancement technology. As dawn approaches, sunlight pierces the dense canopy. This bright light finally signals the end of the insect's intense nightly hunting session. The sensitive eyes of the lacewing are easily overwhelmed by bright daylight. The insect must now find a safe, dark hiding spot. It tucks itself beneath a broad leaf, resting its delicate wings. It waits patiently for the comforting darkness to return again tonight. Meanwhile, diurnal insects wake up and begin their daily routines. They remain completely unaware of the invisible nocturnal drama concluding around them. The cycle of nature continues seamlessly. The shift from day to night represents a complete change in the forest's ruling predator class. We hope this dive into the lacewing's vision has changed your perspective on darkness. The night is never truly empty or blind. It is simply waiting for the right kind of eyes to see it. These eyes understand how to gather faint ambient light. As we advance our camera technologies, we will undoubtedly keep looking back at these incredible insects for vital inspiration and structural guidance. The future of low-light imaging is already written in the biological code of the green lacewing. We must simply translate it. Thank you for joining us on this journey into the microscopic world of nocturnal predators. The natural world never ceases to amaze. We explored the intricate anatomy of the superposition eye, witnessing how it bends and magnifies ambient light for supreme nocturnal visual clarity. We have seen how this biological marvel outperforms traditional human technology, offering a perfect blueprint for future stealth and advanced wildlife cameras. Please subscribe to our channel for more deep dives into the hidden mechanics of nature. There are countless more secrets to uncover. Join us next time as we continue exploring the fascinating intersection of biology and advanced technology. The wild adventure has only begun. Until then, keep your eyes open and stay curious. Thank you for watching Omni Eyes, your ultimate guide to the natural world.